Okay, so this guy, man, is on top of the mountain, which is height of h, right? The radius of the Earth is assumed to be a constant r. The furthest point of the Earth's surface the man can see is actually p, right? So if it's the furthest point, it just means that this is 90 degrees. Okay, assuming that you essentially cannot see anywhere further than that, right? So MP is x km, so this is x. And then after which the angle theta here, and 0 is the center of the Earth. You may assume that the height of the man is negligible. Okay. This is r as well. So you can actually see that show. If you're told to show, right, just use Pythagoras theorem. I see a lot of root here. So I see that this is a right angle triangle here. So by Pythagoras theorem, okay, I know that RH square equals to r square plus x square. That's about it. Then what do I need? We need to make x a subject. There's a square root there, so once done, you just expand this lah. So 2RH seems quite promising. You can actually factorize it. This is x square. Okay, looks quite promising lah. So this is x equals to square root. Okay, but you see, what do they need? 2HR, right? Factorize the 2HR out. They factorize the 2HR out. So maybe 2HR. You just factorize the 2HR out. Okay, here, this will be 1 plus h over 2r. All right. Oh yes, great. It's just Pythagoras theorem. Actually, you yeah. Instead of half there, yeah. I would have. I mean, I see right angle triangle. I just use Pythagoras theorem. I don't really. Yeah. Okay. So this one here is given that h is small compared to r. So h is way smaller than r. Does it make sense? Is it okay? You know why h is smaller than r? No, bro. H is the height of the mountain. Okay? Height of the mountain, right? Cannot be the mountain is like. Of course, the mountain is like puny, like just like a bump on the earth, right? So that's why. I mean, it makes sense that h has to be small compared to r. So that if alpha is h over r, alpha is h over r. Then sine theta will be this. Okay, great. We try and understand this. Sine theta is here theta is opposite over r plus h, right? Right. That's the reason why they asked us to write in the first place. So that's sine theta. Then what I need to do is actually probably just use the first part and see what I'll get out of it. This is 2HR So anyway, so once done already, this is what I'll do. Then this 2hr, this r plus h, right, may not seem relevant, but r plus h is actually, just now we r plus h, we can factorize it out, can we? R plus h. So we need this as 2, so a lah, a is h over r, right? A is h over r. Is it a typo? Yeah, it's a typo. This is alpha. It is alpha. So what we're going to do is actually just put alpha as h over r. So alpha, h over r is alpha. To hr. Everything out. H over r. Yeah, so just change everything to h over r. You want h over r here. So this one here, this is 2. Yeah, I just force a r, h over r there. H over r is it's just manipulation lah. So this one here, h over r. I will just slowly. So this is h over r. This is h over r. I'll get this as 2 alpha. Then I just die want the h over r because they want us in alpha, right? So this is that what you need? Yeah, I got a 2 alpha there already. Good, looks good. Why? Because I can multiply top with 1 over r, bottom with 1 over r. I just want the h over r. I want h over r so badly that I just force everything out to be h over r. This is more of a manipulation question than and this will be h over r. Okay. So leave this as it is because this is what we want. What we need to expand is the one behind. It'll be quite okay lah. So it's not that bad. This is like 2 alpha half. We just need 1 degree here, so we can just stop here. Three-quarter. Nice, I got it. Okay. The last one, just put in the values in. 2 angle. So theta is 2 degrees. And the radius of Earth is this one. So this is r, big R. Alpha and h. Estimate the value of alpha and h. Okay. So that's about it lah. So you just calculate the given that the angle is the something instrument enable him to estimate the angle between PM and horizontal. PM is where? PM is here. And the horizontal is here. This is horizontal. Yeah, so this is the angle here. So this angle here is the same as this angle here. Okay, because this is 90, right? So this is actually the same angle. Okay, so if this, yeah, this is horizontal. It stands on the mountain, the horizontal, right? So essentially, theta is 2 degrees. You need to see that theta is 2 degrees. So we need to know is now 3. Theta is 2 degrees. Now make sure your calculation change to degrees. Sine 2 degrees is equals to, and we know that alpha is actually equals to h over r. Okay, we are given that r is 6375. Okay, now solve this one. How do you solve this? This is in degree, careful. So degree change to, because your GC is in radian, so change this to, don't change your calculator to degree, please. If you want to change the degree, make sure you after that change back to radian. Okay, that's another point. A lot of times students change to degree in the GC, then after that they forget to change back to radian. It's gonna be a mess. So degree to radian here is times 2 pi, pi over 180. Here is times 180 over pi. Okay, so this one here, I'll just divide, change to radian. Okay, so this will be pi over 90. So this will be use GC to solve it. So I'm going to key in calculator. Sine 2 over pi minus 2x half 1 minus 3 over 4. There you go. Graph it. Solution should be here. Here. This should be a root here. Or here. Looks very big. Alpha is very, very small. Alpha is r. It should be very, very small. H over r should be very small. Cannot be this 1 point something, because this 1 point something would be, it means that the height of the mountain is higher than the radius of the earth. So I'm just gonna zoom in and see. I cannot see. Here you go. Here is it. Well, you need to zoom all the way in because you need to know that alpha, right? Your h over r, this radius is very big, so this one will go to 0. The height of the mountain over the radius, this is very, very small. So you need to know this. This is like application. Annoying, I know, because you can't actually see from the graph there. Okay, just so this is specimen paper. A-level paper, A-level question. So this is 6.0954 from GC. 6.0954 times 10. So 3SF will be Okay, so you want h, right? Height of the mountain, you just take 6.0954 times 10 to the power minus 4 times the radius km. This will give us 3.88. Well, that's a very tall mountain. Okay, that's about it.